In this video, we'll look at these operations. So that is get operation, set operation, finding maximum of all the elements and the minimum, that is smallest element in a list. Then we will find out how to find the total, all sum of all the elements, and also average. So let us look at these one by one. Now the first one is get operation. This is a very simple operation. Get means we want to know an element at a particular index. Suppose I want to know what is there at index 9. So the element is 33. So get the element from that index. Now only one thing we have to take care is whether the index given is valid or not. Like length of a list is, maximum index is 14. So total 15 elements are there. So we should not give any index beyond that 14. So it should not be greater than or equal to length. And even it should not be less than 0. So the first thing what we can check is if index is greater than or equal to 0 and index is less than length, then this is a valid index. This index checking we may require at many places to know whether the index is valid or not. This is how we can check it. So this is the condition for valid index. If this condition is true, then the index is valid. If it is valid, just we have to get the element at that particular index. So we can just return the element from an array at given index. That's all. So I have just written a pseudocode. It's not a complete function or something. When I write the program, that time I will show a complete function. So what is the time taken by this one? Just checking a condition and getting an element. So there are only 2 steps, so the time is constant. So that's all about get. Now let us look at set method. So the code will be similar to get, so I'll just change the name of this method. Second one, that is set. This method is to replace a value at a particular index. Suppose I want to replace a value at index 6. So whatever the value is, I want to just replace with this new value. So set, replacing a value or overwriting a value. So for setting a value at a given index, again I should check whether the index is valid or not. If it is valid, then I should change that index location with the element x. So that's all. Now get method was for reading the value, set method is for writing the value depending on a given index. So the time taken by this is also constant. Now let us move to the next method, that is finding maximum. So for that I will change the list because this is a sorted list, so I'll take some other list. Now let us look at max operation, that is finding the maximum out of these elements. So I have a list of size 10. So the size is 10 and also I have all 10 elements present there. So the length is also 10. So from this list, if you check, the largest number is, here I have 15 is the largest number. So this means unless I check the entire list, I cannot say which is the maximum element. For finding a maximum element in an unsorted list, I have to check the entire list. If the list is already sorted, then last element is a maximum element. So for unsorted list, I have to check all. So let us see how I can check it. So for that, I will take one variable called max, and in that I will store the first element, that is a of 0. So this element I will keep it there. So max is now first element, that is 8. Now go on comparing this with all the rest of the elements, and if any larger element is found, then replace this one. So let us do it. 3, is it greater than this one? No. 9, is it greater than this one? Yes. Modify this to 9. Then 15, is it greater than 9? Yes, we got still greater than this. Then 6, is it greater? No. 10, it's not greater. 7, it's not greater. 2, it's not greater. 12, it's not greater than 15. 4, it's not greater than 15. So the remaining one there is the largest element. So this is simple. And how much time it has taken for doing this? If you observe the work I have done, I have gone through all the elements once. So the time is order of n. Now the same thing I will write it as a code which will find out the maximum. So I have to traverse from first element onwards till the last element. So I can scan through all these elements or traverse all these elements by using a loop. So for I assign from 1 onwards, because already 0th element we have taken in max, then I is less than length and I plus plus. Now what I have to do every time? As I is starting from here, I should check that whether that A of I is greater than the maximum, that is this maximum. If A of I is greater than max, if any element is greater than that max, then copy that element in max. So inside max, copy that element A of I. That's all. So at the end of this loop, we will be having the largest element in the max. If you want, you can return this one, return max. So function we will see afterwards. Now let us see the analysis. See, inside the code also, I will write down here, this statement takes 1 unit of time, this statement takes 1 unit of time, and this conditional statement is inside the loop. So how many times it will execute? It depends on number of times the loop will execute. Loop will execute from 1 to last element. So just one element less. So almost n minus 1 element. So this will be executed for n minus 1 times. Then the loop itself will execute for n times. One extra. Why one extra? Because this condition will be checked for n times. So for n minus time the condition will be true, and one more time the condition fail, that is I becomes equal to length, so it will stop. So that termination condition also. So this is n minus 1, and this may execute always, may not execute always. So finally this is how much? 2n, this plus finally this is how much? 2n, and 1 gets cancelled, so plus 1. So the time function for this one is f of n is equals to 2n plus 1, which is of degree 1, so it is order of n. That's all. So from the code, if you want to do analysis, you can assume every statement takes 1 unit of time and find out how many times a statement is repeating. Then you can come up with some formula. From the formula you can write on the degree, and that is order of n. Otherwise, if you know how you are working on this one to get the answer, based on the working also you can tell the time. So basically you should tell the time complexity based on the working. That's more better. Now next operation is finding minimum. So it is just similar to maximum. So what I have to do is, this method is minimum, and first element I should call it as minimum. So this 8 should be as minimum, and I should go on checking if any number that is smaller than that is found, then replace it. 3 is smaller, replace it. 9 is not smaller than 3, 15 not smaller, 6 not smaller, 10 not smaller, 7 not smaller, 2 is smaller, 12 is not smaller, 4 is not smaller. So finally you got the answer. So instead of checking for greater than max, then check it for less than min. And if so, modify min. This is min. And the result is also min. So the code is similar. The procedure is similar. Just instead of max, we are finding min. So the time complexity is also same. Analysis is also same. We have to scan through all the elements. That is n is the time. Now let us look at finding sum of all the elements. For finding the total of all the elements, I should traverse through all the elements and go on adding them to some variable, that is total. So for example, I will have one variable, let us say total, and whose value is 0 initially. Then go to a of 0 and add to this one 8. Then go to a of 1 and add to this one. Then go to a of 2, then add to this. So every time I should add a value to that total. So traversing through all the elements. So I need a variable that is total. That should be initially 0. I should scan through all the elements. So for I assign 0, I is less than length, then I plus plus. Then inside total, I should every time add a of I. That's it. Then return total. Now next is analysis, how much time it takes. We are scanning through all the elements one by one and we are going on adding them to total. So for all elements it's n. Total elements are n, so the time is order of n. Otherwise, from the code, if you see, this statement is simple statement, constant time. This is constant time, and this will repeat for how many times? It is going from 0 to length. So n times, n elements are there. So we assume length elements, we have length elements equal to length, but let us say n. We usually write the time complexity in terms of n. Then I starts from 0, I reach till length, then it will stop. So up to length minus 1 it works, and for length also it will check the condition and stop. So this is plus 1. So as actually inside the for loop, this will execute only for one time, this will execute for n time, and this will execute for n plus 1 time. So that n plus 1 we are writing here. So it means we are ignoring these two. Yes, we are concerned about this condition, so we have written that condition. Then total how much? 2n plus 3, so 2n plus 3. So the time function is f of n is equals to 2n plus 3. Degree of this is 1, so it is order of n power 1, that is n. So this is a simple task for adding. Now the same task we can also write it recursively. Let us look at a recursive definition for finding the sum of elements in an array. Suppose the function name is sum, and it takes array and number of elements n. This n is length minus 1. So here the array starts from 0 onwards, so the last index is 9. If the array starts from 1, then last will be 10, so we can say number of elements. Now this is the last index. This is an array and this is the last index. So let us say this is number of elements. Then what is sum of all elements in an array? Sum of all the elements in an array can be recursively defined as sum of n minus 1 elements. So for n element, sum of n minus 1 elements plus nth element. This is how we can define it recursively. For n greater than or equal to 0. When n is less than 0, then it is 0. Means less than 0 means minus 1, minus 2, if anything you give, then that is 0. So this is the recursive definition. For this recursive definition, I will write down a function int sum a and n. This is a pseudocode. I am not writing a C or C++ function. Then if n is less than 0, return 0. This one. Then this one. Else return sum of a comma n minus 1 plus a of n. That's all. This sum function must be called by passing sum array A and length minus 1. That is the last index of an element, 9. This should be called like this. Call should be like this. So if you want to know the time taken by this one, so this will be calling itself. How many times? It depends on the number of elements. So time is order of n. It is calling itself only one time for all the elements. It's order of n. And recursion uses a stack, so the size of the stack will be number of elements. So recursive calls will be piling up one upon another depending on the number of elements. They start from last index towards the first index 0. So that's all about sum. Now let us look at average. Average is nothing but sum of all the elements divided by number of elements. So already we have seen a method for sum, for finding sum. Now let us just change it to average. So the next operation is average. So for average we have to find the total. So this total will be getting the total number of elements, then simply return total divided by number of elements. That's all. This will give the average. Once you have a sum, then the final operation is total divided by number of elements. So these were the simple operations on an array. Now in the coming videos we'll look at more operations on an array.